This is the worksheet on equations of parabolas. Given the quadratic function y equals -1/2 x plus 3 quantity squared plus 8, state the direction of opening. Our negative sign in front means that we will be opening down. The vertical stretch factor is the absolute value of a. A is -1/2. The absolute value is 1/2. Vertical stretch factor of 1/2. Since that's between 0 and 1, we get a vertical compression. The coordinates of the vertex, we're looking at x plus 3, says go left 3, -3, and plus 8 is up 8. The equation of the axis of symmetry, x equals -3, goes through the x coordinate of the vertex. The range, since our parabola opens down, it has a maximum value of 8. So the range is the set of all y such that y is less than or equal to 8. The maximum minimum y value and the value when it occurs, well, it is a maximum value of y. So maximum value of 8 when x equals -3. -3. The x-intercepts. In order to find the x-intercept, we set y equal to 0. So in our equation, 0 is equal to -1/2 x plus 3 squared plus 8. Going to isolate, so we're going to move the 8 over, giving us -8 is equal to -1/2 x plus 3 squared. Multiply both sides by -1/2, giving us 16 is equal to x plus 3 quantity squared. And we need to solve that. We take the square root of both sides. Square root of 16 is plus or minus 4 is equal to x plus 3. So x is -3 plus or minus 4. -3 plus, oops. I've lost my cursor. Okay, -3 plus 4 is 1, and -3 minus 4 is -7. The y-intercept, scroll down a bit, the y-intercept occurs when x is equal to 0, -1/2, 0 plus 3 squared plus 8, which will be -1/2 times 9 plus 8, -9/2 plus 16/2 is 7/2, 7/2. Now I've gone to Desmos and I've graphed this equation, so let's just take a quick pop over to Desmos. And we can see the equation up here, -1/2 x plus 3 quantity squared plus 8. In Desmos you can look at points of interest, so we're going to highlight those, and we can see that the vertex is at -3, 8. The y-intercept at 0, 3.5, which is 7/2. X-intercept at 1, and the other x-intercept at -7. And remember, when we talk about x-intercepts, we're only talking about the x value, not the coordinates. Number 2, write the equation of a quadratic function with no x-intercept, 1 x-intercept, and 2 x-intercepts. So let's think about what that means. If I have no x-intercept, I've lost my pen. If I have no x-intercept, then I could have a quadratic equation which opens up and whose vertex is above the x-axis, or it could open down and have a vertex below the x-axis. So opens up, let's say y equals 2, and here we're just throwing anything in, x plus 2 squared. Now, it opens up, so I have to be above the x-axis, so we're going to have to go plus some number. Or we could open down, -5, x minus 7 squared. And then the important thing, if it opens down, the maximum point needs to be below the x-axis, so this will have a -7. So plus and plus, or minus, minus, both the a value and the q value will have to have the same sign. To have one x-intercept, we're going to have to touch the x-axis in exactly one spot. So in this particular case, we can't be up or down, we need to be on the x-axis. That means the q value would have to be 0. So let's say we have -1/2 x plus 3 squared and no q value. So to have one x-intercept, q will have to equal 0. And here, a and q, same sign. Two x-intercepts, you open up and are below the x-axis, or it opens down and is above the x-axis. So a and q, opposite signs. So an example of that, and really this should say, right, an equation, because there is no the. Two x-intercepts, y is equal to 3x plus 7 squared. Since that opens up, I need a minus on the q value. So let's say -5. Number 3, which has disappeared off the screen. The graph of y equals x squared was transformed to the graph of y equals -3 x plus 5 quantity squared minus 2. Oops. We have a point -3, 9, which lies on the graph y equals x squared. Put an x of -3, square it, you'll get 9. And we want to know, where is that point going to end up after all of these transformations? And I'm just going to clear off my little cross out. So what I'd like to do is work through that step by step, describing each transformation as we go along. So let's start with y equals x squared. And on that, we have the point -3, 9. Let's do our first transformation. And for that, we'll start off by doing the stretch. So let's get y equals 3x squared. That's a vertical stretch by 3. That's going to take this point to -3 and 27. Our next step is to do the reflection. Y equals -3x squared. That's a reflection in x-axis, which is going to take our point to -3, -27, making the y value a negative value. Next, we're going to do our transformations. So let's start with the horizontal. Let's do -3x plus 5 quantity squared. This is a horizontal translation. Left 5 units, which is going to take us from -3 to -8, -27. Fill those in. And the last translation is the vertical translation. So we're building this up step by step. We've got -2 inwards. That is a vertical translation. Down 2. And that takes us to -8, -29. Writing all equations in vertex form. So the form y equals a, x minus p quantity squared plus q is called vertex form since the vertex is at pq. Right, this tells us left or right, and this tells us the up or down, which will move that vertex from 0, 0 to the point pq. Stretches and reflections will have no effect on the initial vertex at 0, 0. First, determine the equation of the parabola with vertex 3, -5, and passes through 1, -13. So with the 3, -5, we have values for p and q. We have the equation y equals a, x minus p squared plus q. We can substitute in for p and q. So y equals a, x minus 3 squared minus 5. And we know one other piece of information, which is the point. There is a point on the parabola at 1, -13, meaning when y is -13, x is 1. Okay, and all we have to do now is solve for a. So I'm going to add 5 to both sides. 1 minus 3 is -2 squared. -8 is equal to 4a, and a is equal to -2. So our equation now, okay, we don't want the x and the y, we want them to be just general points. So we've solved for a, we get -2 x minus 3 quantity squared minus 5. If you substitute a value of x as 1, you will end up with a y value of -13. Number 5, determine the equation of the parabola shown. Well, we know from number 4 that if we have the vertex and a point on the parabola, that we can solve. So here we have the vertex at 2, -8. We have a point on the parabola of 0, 4, happens to be the y-intercept. We're going to do this the same way. Y equals a, x minus p squared plus q. Substituting in our vertex, y equals a, x minus 2 squared minus 8. Substituting in for x and y then, the value y is 4 when x is 0. And solving for a, add 8 to both sides, and a is equal to 3. Now we can write the equation y equals 3, x minus 2 squared minus 8. And we have solved that. If we went to decimals, we could graph that and see that we would have the same graph. And here we are in decimals. We can see we have a vertex of 2, -8, and we have a y-intercept at 0, 4, having graphed that equation, which you could also do on your graphing calculator just to verify that you did in fact find the equation of the graph, that you verified it by graphing it and ending up with the same graph. Number 6, determine the equation of the parabola with the range y is greater than or equal to -6 and x-intercepts at -5 and 3. Well, let's start by drawing a sketch so that we can visualize this parabola. So it has x-intercepts at -5 and +3. It has a range greater than or equal to y is -6. So it has to open up. it needs to be symmetrical about the axis of symmetry, and we know it has a minimum point, and that minimum point will be at p negative 6, since the range is greater than or equal to q with the opening up. So we need to figure out where p is, but it's symmetrical, which means it's halfway between negative 5 and positive 3. So let's go over here and work out where p is. Well, it'll be negative 5 plus 3 over 2, which is negative 1. So now we have p being symmetrical and in between the x-intercepts. We have q, which is negative 6, and we have either of 2 points that we can use, either of those x-intercepts, negative 5, 0 or 3, 0. So let's always start with our equation, and now let's go and substitute in everything. So we know that when y is 0, a is what we don't know. When y is 0, x is either positive 3 or negative 5. So let's go with positive 3. Minus p be minus negative 1, so plus 1 squared, and the q value is negative 6. Okay, so let's add 6 to both sides. Let's square 3 plus 1, which is 4, squared is 16. So a will be 6 divided by 16, which reduces to 3 over 8. And our equation will be y equals 3/8, that's the a value, x plus 1 squared minus 6. And that is the equation of the curve, or the parabola, that has these characteristics. Again, I leave this to you. You could graph this. You can do it on your graphing calculator and verify that, in fact, you have a minimum value at negative 1, negative 6, and that you have x-intercepts at negative 5 and positive 3. Number 7. The equation of the axis of symmetry of the graph of a quadratic function is x equals negative 1, and the graph passes through the points 0, 3, and negative 3, 9. So I've taken the liberty of drawing this out here, and this is what we have. Now we don't have symmetry here, since this point will be 1 unit from the axis of symmetry, and this point is 2 units from the axis of symmetry. So to figure this out, what do we know? Well, since we have x equals negative 1 as the equation of the axis of symmetry, we know that p is equal to negative 1. We don't know the q value, we don't know that, and we don't know the a value, which determines the shape. So let's start off by writing down the equation, listing what we do know, and see where we go from there. So y equals a, x minus p squared plus q, and all we know is that y is equal to a, x minus negative 1 will be plus 1 squared plus q. That's all we know. We have 3 unknowns here, 4 unknowns, x, y, a, and q. Now in this case, we have 2 values of x and y that we can plug in. So let's taking the point 0, 3, 3 is equal to a, 0 plus 1 squared plus q, giving us an equation 3 is equal to a plus q. Now you know that's an equation that has 2 unknowns. But using this, what else do we know? We also know the point negative 3, 9. So let's plug that in. 9 is equal to a, negative 3 plus 1 squared plus q. Negative 3 plus 1 is negative 2. Squared is 4. This will give us 9 is equal to 4a plus q. We now have 2 equations in 2 unknowns. So I can write these down and solve a system of equations. 4a plus q across cross that off, equals 9, and a plus q equals 3. Subtracting, I will get 3a, q minus q is 0, 3a is equal to 6, which leads to a is equal to 2. Now that we know a, we can go back to one of the other equations. 3 is equal to a plus q. 3 is equal to 2 plus q. So q is equal to 1. We now have the values for a and q, and we also have the value for p. So we get y is equal to a, which is 2x plus 1 squared, and the q value plus 1, giving us the equation of this parabola. Number 8. Cable that supports a suspension bridge is parabolic. The horizontal distance between the ends of the cables is 140 meters. The midpoint of the cable is 14 meters below each end of the cable. Determine an equation, it's very important, an equation to model the cable if a, the vertex is at 0, 0. So let's draw this. So the vertex will be at 0, 0. 0, 0. Now, if this is the case, then we know that P and Q are both 0. So our equation, in order to get the equation, we're also going to need a point on the parabola. So let's take this point here. If this is 140 meters, then from the middle, it will be out 70 meters. And if this is 0, then this is 14 meters high, giving me the point 70, 14. And we know how to find the equation of a parabola given the vertex and a point. So, starting with the equation, y equals a x minus p squared plus q. We now have p, q, x, and y. So let's fill everything in there. The y value will be 14. A, we don't know. We need to calculate that because A really is the shape of the parabola. X value is 70. P is 0. Q is 0. We just have 14 is equal to A times 70 squared. So 14 is 4900 A. A will equal 14 over 4900, which reduces to 1 over 350, giving us an equation y is equal to a, 1 over 350, x, there is no p and q are both 0, so we get y is equal to 1 over 350 x squared. B, what if the vertex is on the x-axis? So that's the same as A, vertex is on the x-axis, and the left end of the cable is on the y-axis. That'll make this the origin 0, 0. The vertex will be halfway, so this point will be 70, 0. And we also have one other point that we know, which is the y-intercept will be at 0, 14. So in order to calculate this, we know where the vertex is. That gives us P and Q. And we have a point x, y. So we do it the same way as we've been doing all along. Let's start with the equation. Y equals a x minus p squared plus q. Substituting in everything we know y value is 14. Again, we don't know a. X minus, in this case, the p value is 70 squared, and the q value is 0. This gives us 14 is equal to 4900A. So A is again 14 over 4900, which is 1 over 350. So the equation this time is the a value is the same. And if you think about it, the a value is really just the shape of the parabola. So a is positive, it opens up, and then the shape, it's congruent. These curves will all be congruent to each other, so they have the same shape. And x minus 70 squared, and the q value is 0, so y is equal to 1 over 350 x minus 7 quantity squared. Lastly, what if the left end of the cable here is at 0, 0? Well, let's sketch that in, and let's find some points. Where's the vertex? Well, it's halfway, which is 70, and this time it's below the axis by 14 meters, so it's 70, negative 14. We also have a point on here, of course, which is 0, 0. Now we know we're going to get the same a value. The shape has to be the same, so the a value will be 1 over 350 x, and we have our p and q, so this will be x minus 70 squared minus 14, since it's gone down 14. And this concludes equations of parabolas.